common example of deterministic structures that you can think about in day-to-day life, or the overhang beams, three-hinged arches. And this is one of the most common examples that we will be dealing with going forward in our course. And to deal with indeterminate structures, you can think of fixed beams, continuous beams, fixed arches. So you can't solve them using equilibrium equations, three unknown types, or two equations, two unknown types. But you will be surprised to know how this complex method of analysis for indeterminate structures can be simplified by developing the simplified general script for analysis. And to develop, we will be basing our analysis on a method, and that is going to be force method and displacement method. Most of you must be aware of it. We'll be doing hand calculations or using it for your day-to-day engineering analysis. So it basically expresses relationship between displacement and force that exists in a structure. The primary objective of force method is to determine the chosen set of unknown forces and couple redundants. Like you can think of unknown forces to arrive in known displacements. The number of redundants is equivalent to the static indeterminacy of the structure. So that's where the degree of freedoms comes in place. So when we deal with the concept of degree of indeterminacy, we will be also thinking how to arrive at the degree of indeterminacy of a structure. So most of you might be using different formulas to calculate the degree of indeterminacy for a portal frame, for a three-hinged arch, for a truss. So we will be combining everything to a single formula. I won't call it simple, I'll call it single formula. So when you input your structure or the boundary conditions to this program, we will be arriving with a degree of indeterminacy that will help you to proceed with the force method, set up the force matrix and displacement matrix to arrive the response of the structures. So the next method that we will be discussing is the displacement method. Displacement method is like when we discuss force method in most of the course or most of your undergraduate course, or you might be knowing about the displacement method. It works by satisfying the equilibrium equations for the structure. To do this, the unknown displacements are returned. So previously the forces were the unknown terms. So currently the displacements become the unknown terms in terms of the load by using the load displacement relations. And these equations are solved for the displacements. Once the displacements are obtained, the unknown loads are obtained from the compatibility equations using the load displacement relation. So, and you might be wondering, like, when we are developing a general script, why do we need to know about both the methods? So this is another option that I keep based on the feedback from the attendees and students of the course. So if you're comfortable with one method, we can proceed with one method just by introducing the concepts of both, or we can set options. Like if you're comfortable with force method, go ahead with the force method. If you are comfortable with the displacement method, go ahead with the displacement method. It's basically your choice that you're going to make. When you're in your day-to-day practicing life, nobody is going to ask you to solve it using a particular method. All you need to know is basic fundamentals to arrive at a solution to respond to the structure. And all the displacement methods follow a general procedure, and same as force methods. So this Mastan 2 is one of the engineering tool that I can recommend you to refresh your concepts of structural engineering before we get started with the course. The reason I suggested, because you might be wondering what's the necessity for a computer to learn computer and software related programs for a mechanical or civil engineer. So when you finish your school and you enter your design office or site, it's highly possible you will encounter a design software of considerable sophistication. So if you input numbers, you get response. And this is where like many people might tend to go wrong, because when you receive numbers, you never know what whether the number makes sense or not. For example, you input a beam and then you get a response moments to the loads that you have input. So how sure you are that this is the moment demand that's acting on this structure? So this is the course that might help you to stay with confidence. Yeah, this is a structure that's subjected to uniform distributed load. This is a gradually distributed load, and this is a structure that's going to respond this way. I'm expecting a parabolic moment. I'm expecting a maximum of 1,000. So here, maximum, it's a hinge connection. The moment should be 0 here. So this is the course that's going to teach you the most important concept of engineering, solution interpretation. And that's what it's all about. And that's a necessity to study any analytical methods. So all the hardcore breaking the head to learn engineering concepts, to develop a code, to analyze a structure, is all about when you develop this code, a flowchart, algorithm, or MATLAB code, and you arrive at the response of the structure, by practice or by tutorials and projects, you're going to be well versed with the concepts, and that's going to improve your engineering decision skills. And in the future, even if you encounter any software program that you have not discussed in this class, when you sit down and understand the basics of the computer program, you can master it in no time compared to people who have not done such rigorous exercise to understand analysis and design. So of all the programs, why I suggest Mastan 2 to refresh your concepts before taking start this course, it offers you pre-processing, analysis, and post-processing. So when you can, it's basically like a computer application, like you play around and get to understand. So what I would suggest, it's an engineering tool to how different structures will react under specific loading conditions. It uses MATLAB engine to do its calculations. So we won't be using this software for the course, but we will be learning how MATLAB can itself be used to analyze a structure. But this is a program that can be used with and without MATLAB. So if you follow this website, you can learn more about this software, simple tool to analyze structures. And with this comes a free structural textbook, and you can use it as a reference manual for your future understanding of matrix methods or force method or displacement methods. So it also acts as a good reference manual to prepare for your competitive exams like GATE or IES. And getting back to Mastan, so all the pre-processing options, it has pre-processing, analysis, and post-processing. The pre-processing options include definition of structural geometry, support conditions, applied loads, and element properties. The analysis routine provide the user the opportunity to perform the first or second order inelastic analysis. So if you're not previously aware of elastic or inelastic analysis, you can wait until the first week of the course, where I will be explaining you in detail what these methods mean by and how you can warm up using Mastan 2. So post-processing capabilities, it's something that's not necessary because we will be creating the flowchart and code ourselves. So we don't need to touch that part. So as I said, the code, you can go to this website and they have a special tab for textbook, and you can use it to learn more on force methods, matrix methods of structural analysis. And you can see there are like complex structures given as example in this textbook. And we can use this as a good reference material when we get started with the course and see how we can make it simpler using the code that we develop throughout the course of this class. So basically what we need before you get started with Mastan is all you need is to know the geometry of the structure frame, connections, or basically you can play around with any type of connections to get warm up with. and your connections define the fixities, and you can define the sectional properties of the material, like the cross-sectional area or the inertia or the torsional constant, and or the material properties like the modulus of elasticity, Poisson's ratio, and the yield stress. So these properties will help you in understanding the response, or you can get a basic understanding of response of structure. For example, you can increase the area and see how it defines the response of structure, or you can decrease or increase, or probably you can write down and you can discuss with me during the first part of the course. That will help you to get a clear understanding to dive through this course. So as I said through my previous slide, working with Mastan, you need all these concepts, starting with nodes to the loads. And one thing that you can keep when you warm up or like surf through Mastan, it's like a unitless software. So if you input your load in kilonewton and then your frame is in meters, and you expect your load value or the boundary conditions or the moments value to be in Newton millimeter, you won't have it. For example, like be consistent, use kilonewton meter, Newton millimeter, or Newton per mm square. So these are all the unit you can write down, and probably you can do a hand calculation, probably like what will the moment be if I do this formula, and you can compare it against the results that you obtained from the software. And there might be slight discrepancies based on, this is quite conservative, and we can be discussing why it's different for some structures when we dive through the course program. And probably you might be wondering why you need to take this course, or what will you gain from this course. So that's one question that I can help you answer, or help you like explain it in a simpler words. Like, it's basically on analysis and design. It's a fundamental concepts for any civil or mechanical engineer. This course will help you refresh your fundamentals and prepare you for your future projects. It is going to enable you to, it reinforces your concepts and make you potential enough to analyze complex structure in simple methods. You can basically look at a structure and have an understanding how it's going to behave to the loads that is acting on it. And another technical concept that we will be learning through this course is parametric design optimization. And we will be also discussing some industrial design projects. And also throughout this course, I will also be discussing frequently asked interview questions and how this course can be helpful, or how it will be one of the very few basic questions that they might be asking you through your basic interview for job interviews, or when you go for higher educations or masters, how this course can help you refresh your fundamentals for your further education. For throughout this course, we will be touching few computation tools. For analysis, for civil or structural engineers, we might be brushing through SAP 2000, or for design, parametric design, we'll be going through Rivet or Abacus. For mechanical engineers, for analysis and optimization, we will be discussing SolidWorks, and to compare the behavior of structures using finite element analysis. So we will be, for some part of the course, we'll be discussing ANSYS, and probably you might be suggesting me some more computation tools after this that you are interested to learn, or you are interested to know how the computation tool works after this session. And I'll be happy to prepare a lecture or webinar on the same, and say how this is going to be closely related to the coursework that we are planning for you. And as I said, what opportunities you can expect. I have said many times, it's going to refresh your concepts. And though the last point seemed like it is not going to GATE or IES examination, you might not exactly use the computer, but it will help you to strike through the options, because you will know this is not a possible action to this question, because you have already developed a flow chart and you know how to analyze a structure in a faster way. You know what to omit and what to strike when you see a structure with a boundary condition.